Oh, okay.
Hi, how are you doing?
Hi.
We're waiting like maybe a couple minutes for people to join. Okay. Hi, everyone. Hi, Lane. How are you? Hey. Good. Glad you're doing okay. Michelle is here now, so let me save my stuff here. Michelle, how are you doing? Okay. So very hot. Yeah. You would think that it's gonna cool down after, but it says my internet is unstable. I'm at the campus, so hopefully, maybe I'll turn off my video for a second. Um, Welcome, Kevin. How are you? Okay, so what we're gonna be doing is, well, before we start, right, let's talk about a couple of things that people were having issue with from last week. There were some virtual machine issues. I don't know if some of you recall from the prior class, but there is a video adapter configuration in VirtualBox. Let me pull up my VirtualBox and share screen. So um, if your virtual machine is giving you issues, then make sure that you check your display adapter. Okay. And once you configure that, I think it's gonna generally be okay because I think the drivers needs to be there. So here's the virtual box, right? When before you start your virtual box, then you can go into your preferences, which is under tools, and then you are going to click on display. I know that for the here you can actually change the actual display, but let's say that if I go to my Ubuntu and I go into settings before I start my virtual machine, I want to also go ahead and check the display on it. If it's giving you issues, you want to check this option for acceleration. I don't have this feature on my video adapter, but if your video adapter has this feature on your computer, likely that you might have some issue. Okay. And then you can also change your video memory to a higher megabyte. So you can just glide this. So making sure that we check that. I read the threads and it seems like that's a problem. And I recall that when we did it in the other class, CIS30B in the past, we also had some issue with this. So, you know, this is the area that you might want to check if you ran into a virtual machine from the exercise from last week. Okay, so that's out of the way. Do you have any question for me before we start? Sorry, it's just been like one crazy week and I'm just trying to get all my stuff put on Canvas and things like that. So it's just, and grants and things are coming into place. So anyway, um, let's talk about what we have to do today. Your notes are located on Canvas in Unit 3. I will post today's video. There's only going to be one activity that we're going to do this week because Monday was our holiday. So this week we're going to do a little bit of programming and then we're going to touch on the tools a little bit. So, it's going to give you a little bit of practice and also some review. I know we cover some of the concept, but we're going to expand on those. Okay. So the target for today is we are going to look at how we can improve algorithm. And then we're going to talk about why caching is important and how we can manage memory for our application. and then a little bit on comprehension and generator. So we are going to spend some time doing some basic programming, and I'm going to walk you through those. So as you take a look at the notes, it starts with talking about algorithms, and like any program, we want to, look at how we're writing our functions and the type of loops. We talked about how we need to optimize from last week when we were doing the profiling and the benchmarking. So in this week, it start talking about data structure and algorithm. So algorithm is just a procedure that you would implement in your program to solve a problem. And an algorithm can include, for example, a for loop or a nested for loop where you would iterate through it. Or another algorithm might use recursion, okay? So in that sense, what we need to do is we need to really look at the runtime of our algorithms and how that can be effective in performance improvement over time for our application. So last week we touched on how we can use the Linux system to assess, right, like a statement, and using timeit command. So now that you have your virtual machine, most of you do, right, you're able to use that. And so here is an example of how that would be done. In the first part, it talks about how the runtime for the algorithm is classified under computational complexity. And the way that we would measure performance is that we would use time complexity to look at the amount of time that it would take to run such algorithm. And it would be varied, right? Some program would have better algorithm than other. And if you're looking at across the board for the same type of solution, we want to look at the version of our application that's going to give us the best performance. So in this, what you would see is that we would use what's called the big O notation to determine how fast our algorithm would be. And you would often see it written as O, and then inside it, it would be some kind of function. So an example of how we would look at that is using a for loop, okay? And so in this example, this is from the book. This example is just acquiring the user input, and it's going to put that into a list, and then using the list keyword, right? And we are going to repeat 10 times. And in order for us to really automate the repetition process, we would then use a for loop. So when you see a for loop implementation, you would see that just a single for loop, we would say that our big O or our O notation would be O of n. In that, n would be the number of inputs. So as this particular program only requires 10 input, that would be fairly a lot less than something that would require 1,000 or 10,000 or 100,000 input. So it would be fair to say that we would determine the performance of this using big O notation, and n is going to be your input. So the size of input is greatly impacting your overall outcome of the program. As you can see, that it would take longer to run for 100,000 input compared to 10 input, okay? And so now in the textbook, it talks about how they are assessing the program based on the average case scenario. But in the industry, we normally look at it from a perspective of the worst case scenario, which means that what would be the results for the worst execution of the algorithm, what would be the worst case? And the worst case might be that you have an infinite list. It will go on forever. And in that case, we won't be able to have a concrete measurement of time. So what are some of the other considerations when we're looking at how our application is performing? Well, processor speed plays a really important role. So if you have an older system with an older processor that needs to execute the task, of course, it's going to be slower than something that would be faster in processing speed and to be able to acquire all of those input that you specify in the program. So let's switch back to the assignment, and it's going to ask you for number 1, what is used to describe the amount of time to run an algorithm? So we would use time complexity, and we would use big O notation to denote, right, the amount of time that would be to execute a task in our program. Any question? Now, some of you might be familiar with this if you're taking CIS30E, right, which is for C++. So concurrently, this class is going to have some, it's going to share some of the concept with 17C, in that we are going to look at how to optimize and how to use data structure and algorithm accordingly. Okay, so the first answer we have is time complexity. Now going further, right, and I pulled this from other sources outside of just your textbook. So textbook is generally just looking at the example and giving you the outcome based on the assessment for the example. So the things that we can look at is what's called the big O notations order of growth. And when you're using different, if you're approaching to solve the problem with your algorithm, you can also, different algorithms going to give you different outcome. So when you're using a constant, so for example, when do we really see a function that would be a constant? When you are, let's say you're running a program and you have a for loop to access a list element of the list, then in that case, we already talked about it's O of n, which is a linear function. But if you have a function that's only going to display or access one element of many elements in a list, that's going to become a constant function, as in that it's only going to be able to do one task in that particular task, that one input, that's going to be O of 1. In other cases, you would have, I have logarithmic twice, you would have logarithm, in that we would use something that would be like equivalent to a binary tree, or in the case where if we use binary tree to search or sort a container. So what do I mean by binary tree? What you can do is you can create these nodes, or what would be subcontainer that would be held into could be an array or a list or a doubly linked list, and so on. And we would want to be able to use these nodes to reference the subsequent nodes that would contain data. So when we create something that would store values, for example, from 1 through 100, we can put some of those values into the nodes, and each node can reference other nodes. So it's going to branch out like what you would see in a tree. And we can traverse back and forth, right, depending on how you would solve that problem. In the binary search, what it does is it's going to break everything in half, and subsequent half and half and half of that, then it's going to be able to access the data by looking at the half that was broken down further, right, at the minimal unit, and then be able to traverse back to be able to find the actual criteria that you're looking for. Subsequently, that would be a lot faster than what we would see if we would just use a linear or a loop to iterate through that container. So in such case, we would see that that will be a logarithm or logarithmic function. In other cases, you would find quadratic. And quadratic is normally seen in nested for loops, right? In that, in order for the system to really access each of the index, it has to go from inside out, meaning that it would have to execute the inner for loop, and then it's going to be able to utilize the outer for loop. As the inner for loop would be O of n, you would then have to iterate on the outside, which is going to be O of n again. So therefore, we would have a quadratic function that would be implemented in that case. And in other cases, you would see cubic or exponential functions. So as you see that, I'm just summing it up, where a lot of the times we would spend quite a bit of time to really evaluate this. But as you can see, those are some of the examples that you would come across when you're looking at order of growth for your system performance. Okay, any question? So first, what we're going to do is we are going to look at containers, or what we would see as where we store your data structures. Okay. And similar to C++, we would know that list is equivalent to what we see array. And for the Python list, what it allows us to do is to place the data into a contiguous location for memory. That means that when you create a list, it would store in a location where it would subsequently slot your element continuously. So that way you can use an index starting with 0 to be able to access each of the value. Then if you are, like we said before, if you are only accessing one element and we would modify it, in that case, our big O notation would be O of 1, as we are only using that one particular index. And so the way that our list is created, that we can append to the list. So that means that we can loop through it and append each of the element to it. And list is modifiable. So that means that it can expand in size, or it can use fixed size. So in the case where if you have input, like what we've seen before from the user, and as each input that is then stored into a list, then your function would be dependent on the number of input. Okay. So now we can look at how we can efficiently utilize a list from beginning to end of the list, whether we can insert the elements or we can remove the element from the list, and so on. So the example that you would find in the book, and I captured this table from there, is that let's say that if we need to remove or add elements into our list, we can use list.pop to get rid of the last one on the farthest right? Or we can pop a certain element at a certain location by passing its index parameter, which is the second row right here. Or we can append, right, a specific value to the list. We can also use insert. So when you're utilizing these methods that's built in for our list, what we would see is that when we want to measure this, if there is 10,000 input, is that going to be close to 2,000 input, and so on. So when we do a pop, we would see that it's pretty consistently close. But when we pop at a certain location, we would see that it drastically changed when we go from 10,000 to 2,000 to 3,000, as it has to seek for that location in a larger number of inputs, okay? Which means just a larger number of elements in that list. So for the O of n here, you can see the measurement right? When n is 10,000, which is a lot less than 20,000 or 30,000. When we append, as it would just drop it into the last slot, which is the farthest right of your list, it's going to be pretty consistent. So when you see that if it's a constant function, it's going to be close no matter what number of input you have. But when we see a linear function, of course, it's going to be completely dependent on the value of n or the number of elements that you have in that list. Okay. Any question with this? Okay. So let's try, right? And what I want you to do is once you write your program, if you do have time, you can fire up your virtual machine and then you can go in and you can assess it like what we've done in the last week. Okay. For number 2, it asks you, given the below Python program, determine the time complexity of the program. You have numbers is 6, 5, 3, 8, 4, 2, 5, 4, 11. This is non-sorted list. And we have total initialized at 0. We're using a for loop to do a running sum, or we just accumulate the total as we loop through our program. And so then we're going to print out the sum. Okay. So in this case, we have one for loop that's implemented right here. Okay. And it's going to be dependent on the number of inputs, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 elements in our list. So what it will do is it's going to iterate, right? It's going to loop 9 times, starting with the first element, which is 6. Okay. And then it's going to add 6 to 5 and so on and so on. And then when it gets to the end, we have a larger sum. So in this case, right, we would have O of n for the time, where n is the number of elements in the list in this case, which is 9. Now you might have an infinite list, right? As sometime we would have data that would be continuous and it's never ending. Then in that case, we would run into the worst case scenario for this particular program where it's going to keep adding infinite time, right? And so in that case, we still would have O of n. It just, we would never have the ending result. It's just going to keep going forever and ever. Okay. Any question? Then for question 3, is ask you, given the program from question number 2, what is the time complexity to access any element in the numbers list? So if I want to access the first element, which is 6, then my notation is going to be, Bambigo notation is going to be O of 1. That will be my time complexity is going to be O of 1. Now, if I want to access the middle element, let's say the 2, it's still going to be O of 1, as it's going to only execute that one time to access that particular element using the index. Okay. So like something like you would say print, right? Numbers, and then you would pass the index in the parameter so you can print out that particular value. Or if you want to append, or if you want to remove one of the value, it's still going to be O of 1. So anytime that you're using only one element in that list and it doesn't have to iterate, that's going to be O of 1. Anytime that it needs to access the entire list, each element subsequently, that will be O of n. Any question? Okay. No question on this. I see a chat question. O of n is used to compare. Yes. For the programs that are using a certain number of inputs, or um, that will be, it's used to look at the time that it needs to execute, right, for your algorithm. And in this case, our algorithm is a for loop. So that will be O of n. So let's say that I have this program. One program is going to have 9 numbers, okay? Having the for loop to total up all the 9 numbers. And then another program similar to this, but the input will be 9,000 values, and it needs to total up 9,000 elements in that list, right? The 9,000 element program is definitely going to be slower compared to the 9 element program. Okay. So that n value plays a role when you look at something like this, an iterative program. Other question. But if we compare, right, the 9 elements and the 900 elements program, and if we're only accessing one of the element in each of the program, it will be very close. It will be O of 1, and the time is going to be close. So when we say not to the different program, but we want to say, okay, can we compare that to different versions of our program? Sure, you can do that. So the whole point in the whole benchmarking and profiling last week was to really look at how we would measure, right, our improvement throughout different versions of our program. And now we are going to look closer on how we're creating the algorithm and how we are going to write the store the data in our program. Okay, so I'm going to switch back over to the notes now. And here it talks about deque. Okay. I know I touch a little bit on this in CIS30E. There's like a subsection in one of the chapter. So deque uses a collections module, and deque is used as a doubly linked list. How do you know when a change in O of n is significant for a particular program? When you have a higher number of input, Michelle. So if I let's say if I run the program, right, for like what we would measure for 1,000 input, then I would run it again for something that will be 10,000 input, 20,000 inputs, so we can see how that would be different. That means 1,000 elements, 10,000 elements, 3,000 elements, and so on and so on. So if it's significantly changed, like what we've seen previously, okay, in the last table, like what you see would be here, okay, like how the time would be, then you would see that there's significant difference. So I go from 6.2 to 11, that's double, right, the time. And then that's also, this is triple from what we start with 10,000. So it should be, right, because now we have 3 times the original input. Do you have to use statistic to calculate the significance? You can, but what you want to do is you want to compare, right, based on the time. That's why we have that time command. If you want to write up the report and say, okay, so out of the test, right, this is statistically the differences between, 10,000 input to 3,000 input. Sure, you can do that. And you can take a look at the margins on, you know, how it execute that particular algorithm. But ultimately, the objective of this is to show you that, you know, there are, when you implement algorithms, certain algorithm is dependent on the number of input. As you would have more input, it would take longer time.
Okay,
So
thank
for,
you.
yeah, and for something that would be like, you know, let's say time sensitive, yeah, you want to measure that, right? Like emergency room applications, things that would be life and death matter. So we want to really measure the significance between, you know, how the data would be accessed ultimately. Because as you would utilize the application over time, um, there would be increased number of input. And as you increase the number of input, there's a slowdown in that. Okay, with this particular algorithm. So we have to find ways to improve it by changing the algorithm. And you will see how. Okay. Other questions? So deque is part of collections and simply it is a dual list. There's ways that we can create a container. I don't want to say dual list. It's a list that we can access on both sides. So when we say a doubly linked list, all that means is we can add and remove elements from left and right? Because as you insert the element in a regular list, it's usually just drop it into right the most right location, as it would be the last one in. So it's going to be at the top and it's going to be the first one out, last in, first out. So think of it like how you stack dishes, right? When you wash dishes, the first dish that you wash is on the bottom, and then the second and the third, and then so on. Let's say you have to wash 10 dishes, then the last dish is going to be at the top, which is the 10th one, right? And when we remove it from that stack, what we would do is we would take the top dish, which is the 10th dish, out first because it's on top. So that would be um, a way to really visualize how your data would be. Now, on the doubly linked list or a deque, what it does is that it allows you to do from top and the bottom at the same time, or left and right. So I can put in values, right? Or items, I should say, and then I can add to the front of the list and the back of the list, and we can remove them both sides. So with that, what we will be able to do is it's going to be quicker as we were able to access these elements. Now, similarly to the last one, when you pop individual element, that's going to be a constant function. Okay. But remember that ultimately a deque is still a list in the back. Okay. Just like how you see in C++, a deque in C++ is still an array in the back. It's still a container that's going to store value. But instead of only utilizing that container from the right-hand side, we're able to do it from left and right. So, well, what it's saying here is you shouldn't use in place of a list in most cases, because it's still a list in the back. The efficiency is gained when you are using the proper operation for the deque. Okay, meaning that we can do left, right? We can append left, we can pop left, we can append right, or we can just append, it's just going to append right, and pop, it's going to pop right. So when you specify left, that means it's going to move to the front and it's going to be able to either append or pop. But if you just use append and pop without left, it's just going to utilize on the right side. Okay, so the important takeaway from this is the deque actually use we are able to access it both sides. And the operation really drive the efficiency for that data container. Okay. So this table gives you the visualization of how that would be as far as performance goes, as far as time. Okay. So when we're accessing one element, it's going to be the constant. We saw that. So it's pretty consistent, more or less very, very close, right? And the same thing with this here. So if we're utilizing the right side of the deck or the left side of the deck, right? But when we start to operate it with something like this, where we want to take our data and we're going to cut it in half, okay? Like we size it in half, like in the case of binary, and then you would size it again and size it again in half. So you keep dividing it in half until you can't anymore. So in that case, if we're only going to divide it in half the first time and parse it as an integer, we would see that there's some changes as we would have higher input. Because think of it this way, right? Like physically, the analogy for this is, let's say that if you have, a very long rope, well, let's say 1 meter of rope and you cut it in half, it's not so bad. But then if you have 10,000 meter of rope and you need to cut it in half, you have to measure it through and making sure that the half is the point, so it takes longer. Same thing with the system. If you have more input and if you need to cut it in half, it's going to have to size it to the half of the larger input size, and it's going to be increased in the time that it's going to need to do that. Okay, because it's dependent on the number of n. Any question? Then we're going to get into what we call searching. So a lot of this is what we utilize all the time, right? Like things that data, in order for data to be accessed, we have to seek it. And the fastest way that we can find something is to first sort it. So we would be able to write the algorithm or utilize already the pre-built algorithm that we can actually implement in the program. So to search an item on the list, we can generally loop through it, right? You can write a for loop and you could say, okay, look for every single element and find number 4, right? From 1 through 100, for example. And it's going to iterate through 1, 2, 3, 4. It's going to stop at 4. It's going to say, oh, found it, right? But if we are looking for, let's say 101 and our list contains 1 through 100, linear wise, you're still going to have to go from 1 to 100 and it can't find it. So it's still going to have to go through every single element if you loop it. Okay. That's the downside of it, is if the value is not found in the linear algorithm, it's still going to have to look through everything. Okay. And it's going to say, nope, not found. Now, if it found it somewhere in the middle, then it stops it there, but you still have to iterate through all the prior input in order to get there. So it is n dependent. So a better way that we can do this is we would use what's called a bisect. Okay. And this is implemented through the bisect module. It allows you to perform a faster search if the container is pre-sorted. Okay. So what that means is, okay, let me take you to the bisect. Okay. So if you look at the documentation, I provide this on the note. It basically take the sorted list, okay? And for the long list item here, what it's going to do is just going to compare. So that way, it's going to look at the left and the right, okay, of the list, very much like what we've seen with the deck. And it's going to be able to return it. So think of it like how we are working from the outside in from both sides, like left and right. let's say that if we're looking for the number 52 from 1 to 100, right? So it's going to do left and left, right, and so on. So it's a faster way for us to really look through the elements in order to find our key value. Now you can also use it to really insert, okay? And mostly we can insert it to a certain part of the list, and it's going to return, right, the position where it's inserted, and you're going to see it in the next exercise. We can also insert it particularly to the right section of the list, and it's going to give you the position for the index that's inserting. Okay. So with that said, we might have something that would have the same data, okay, same value. So let's say that I got my value for my test score at 80, and I have another test score that's 80, right? It would put it right next to the previous if we tell it to, or it would drop it, right, in the subsequent location. Okay, so we're going to see that in our next exercise now. So in number 4, it asks you to look at the documentation, and we are going to write a program using bisect module. Okay, binary section module. And we are going to first use the given list that's there of test scores. And then we are going to try to insert an element that has a value of 86, and it's going to tell us where it inserted, which position it's inserted in. And then we are going to try to insert something on the left side because it's pre-sorted, or not pre-sorted, we're going to sort it. And then we're going to insert on the right and look at the actual index position. Why is this important to you, right? You might come to across things that you have to identify where that data is, okay? And as you insert the data, it tells you, it confirms that that's the position where the data would be, okay? All right, so number 4, which is test scores. Here's my program, right? So what I start with is an import statement. We say import bisect, and then you would declare your list test scores, and you don't have to name it like that. So I just put in the values that's given to me in the exercise. And in order for us to use bisect or bisect method, we have to make sure that it's sorted. Okay. So we would, and Python has 2 types of functions. There's one that you would use sort, which uses slightly different parameter, or you can use sorted method, which you can pass the entire list. Okay. So once I have it sorted, I wanted to print it so I can show you. Okay. And then I'm going to go ahead and insert the score 85. As you notice, I already have 85 there. Okay. I put 86. Was that 86 or 85? Oh, 86. Let me fix that. Should be 86. So it would then need to drop 86 into our list. Okay. And then we want to print the position of where it inserted. Then I'm going to use, so in this one, because I'm using the bisect module, I gotta make sure that I put that there, right? And then I'm using a bisect method. And in that, if you look at the parameter in our notes here, when you're using bisect, you need to tell it what list you're using what number you inserting, and the beginning and the end. And these you don't have to put in, but you have to have the other two. Okay, so here it tells you there are four arguments that you need: list, number to insert, starting position, and ending position. So your beginning will be 0 and your ending is the position of the index at the end of your list. Okay, so what it'll do is it's going to look in that, it's going to try to insert it. So now if you don't pass these two in the argument, then it will just refer to which list you're using and what number you're inserting. If that number already exists, then it's just going to drop it. So it says, we will see. I wanted you to experience this. Okay. So going back to my program, so for the bisect, I wanted to use the list called test scores, and I'm going to insert 86. Okay. And then after that, I wanted to print the position where it would be inserting. And then I have a position left. Then I'm going to use bisect left, and I'm going to insert test score 40. And then I also have a position right, and I wanted to insert another test score right. Now, you don't have to use a variable to hold the actual index value that it's going to insert. The reason why I did that is I just like for it to be cleaner, but you can definitely pass the print with the bisect, because it's return when it executes this, it's actually return the position, the index value, and we just wanted to print it. Okay, so we can see, but it does it. All right. So here we go. Disregard the inverted index, that's later on. So we take our list and we sort it, and it's going to give us 42, 61, 78, 85, and 90. Okay. Keep in mind that now 42 is 0, right? 61 is 1, 78 is 2, 85 is 3, and 90 is 4. So when we try to add 85 into, or 86 into this list, what it's going to do is the 86 is going to take the 4th position. Okay. If you count it 0, 1, 2, 3, 4, right, it's going to put it right here before the 90. Then when we did the bisect left, we would then add the 40. So it's going to push this 42 back, and it's going to put the 40 in the front. Therefore, the 40 becomes the first element, which is element 0. Okay. Then we can also add another one on the right, which is 91. So then at this point, when 91 is added, it will be the last one on the list because it's the highest. It's going to be there after 90. Okay. Any question? So that's how you can use bisect module to add or insert element into an existing list on both sides in Python. And keep in mind that you have to start with the sorted list, so you have to push it put it into sort, and then you can use those method. Otherwise, it will not work because it's using the way that the bisect method and bisect left and right is working is because it's a contiguous memory location. It's going to put into that memory location where it finds a value. And this is number 4. So when we're finished with that, take a screen capture of your script and your output. And again, you can find a lot more details in here. And if you want to try other example, you can also look at their other example there. Okay. This is bisection algorithm. Very similar to what we've seen with string splicing, like what we've done in the past for the list in 30A, right? But in this case, we're using a different module and then we're able to insert left and right. Any question with 4? Okay. So next we are going to use their other method. So you can see we want to use insort, and insort is another method that's included with this module. You're able to insert the score, same as what you would see with bisect method. And you can do insort, insort left, and insort right. If you refer to their documentation, you can find insort right after bisect here. Okay, so it says you can insert X in A in a sorted order. Okay, and this is equivalent to doing an insert with a bisect nested in. So it's really an insert on the outside of the bisect. And we can do that on the right and the left. Okay. Now it says that similar to the insert left, when you're doing it on the right, the insert X is in A after any existing entry of the X. So it's just gonna put in the value on the most right hand side. So in number 5, we are to use the list from exercise 4. We are going to insert a test score 88 and display the updated list. We are going to insert another test score on the left, 30. And then we are going to insert another test score on the right. So when you're using insert without left, right, it will just put it on the right. If you insert it on the right most handed side, you can also use right. Okay. Can you insert in portion of the list? You sure can, as long as you pass the other 2 parameter. Okay. All right. So let's take a look at number 5. So I started with the same list I didn't reuse the updated list from number 4. I just started with the original list. I send it to sort and I print. Then I simply use bisect and sort, and then I pass the list name, the score, and here is my start, here is my end, right? So 0, 1, 2, 3, 4. So I want it to be including with the new element, which is going to be the 5. I'm sorry, the 6, which is 5. Then I'm going to print. Then I wanted to insert to the most left. So again, I'm going to use bisect, but this time I'm going to use insert left, the list name, and then I'm going to put 30, which is the value, the test score. And I'm going to start with 0 going into 6. Remember that I just inserted my last one, which now is the next one. It's going to be now 7 elements. Okay, so you went from 5 elements to 6 elements to then 7 elements as we insert again. And then on the next round, I'm going to add it to the most right, which is 100. And that's going to give me 0 through 7, which is now 8 elements. So let's run this program. So I have the sorted list here. Then I insert 88 and it dropped it in here before 90. Then I added another one in the front, which is 30. And then I added another one, which is going to be 100. But what if I do this? And we would print test scores. Okay, we're going to add 100 again, see what it does. It just dropped it to the most right. What if I added 88? It puts it next to the other 88. You see that? So this is a good way for you to add data to your container, right? Without having to iterate through the whole deal, right? Like you don't need to seek for the value with the for loop and then insert it with another for loop. We can just use a pre-built one like this where we can just access it on both sides. Any question? Okay, no question. So this is number 5, where we use insert. Okay. Okay. So in the next section, we're going to talk about dictionaries. Actually, we're going to do a deque first, and then we'll talk about dictionary. Let's do a deck, number 6. If you took 30A, right, which all of you did an exercise on deck, right? There's the small section, we talked about that. So we would want to look at the deck documentation. We would write a Python program using collections module to achieve the following task. We're going to make a new deck that contains 3 items, C, D, and E. We're going to append A and B to the left of the container, show the list. Then we're going to append F and G to the right of the container. We're going to show the list. And then we're going to use extend method to add H through L. And we're going to display the updated list. And then we're going to rotate, we're going to flip the position of our characters in our list. And then we're going to remove on the right and then on the left. Okay, so when you pop on the right, just the last one that comes is going to pop on the left. It's going to be the last one on the left, or the first one on the left side. And then we are going to clear to make it an empty, and we are going to print. Okay, so pretty easy. So if you need documentation, I forgot to put the link on the assignment, but you can go to collections. You can refer to the example that they use here, which is very helpful with the assignment. Okay, or you can read through. There are additional stuff about counter and so on. But collection is the module that we're going to use for deck, doubly linked lists. Okay, ready? Any question? This is number 6. Okay, so first I'm going to start with an import statement. So I want to say from collections import deck. And we are going to create an object. You can name it anything you want. Then we are going to initialize that a CDE for that object as a deck. As it contains multiple element, because remember what I said, so list in the back, right? You are going to have to iterate. So we are going to have a for loop to be able to access each of the element to print. And I wanted to show you what's in the deck, right? Otherwise, we don't have to have a for loop here. We wanted to print using a for loop. Then we are going to add B and then A. Why am I doing B and then A instead of A and then B? If you do the first one as A first, it's going to be in, and then when the B comes, it's going to push that back. So I want it to look like A, B, C, D, E. So I have to append B first and then append A. A as the last one in, it's going to be the most left as I'm using append left. Okay. So it's going to push B in and then it's going to push A. So it will read A, B, C, D, E. And then for the next section, we're just going to append on the right side. That will be F and G. So we can keep them in that order. So we would do deque.append because we created that object. So we would append F and G. After that, what we would do is we are going to do extend. And extend method is used to add many items, right, at once. If you want only one item that you want to add to the deck, you are going to use append left. If you want many items, basically it's another list. it's going to do extend. And what it would do is going to drop those items subsequently to your existing deck elements. So where G is, it's going to drop these in following G. And after we extended the list with all the other characters here up to L, we are going to rotate. So when you're rotating right, you're going to use the 1 as the parameter. Okay, it's going to flip the one on the right. And then when you're rotating left, you're going to use the -1. Very similar to what you've seen with string slicing. You would use that value, right? Going from the most right is, and that's going to be 1, and the most left, that's going to be -1. And then after that, we are going to pop the one on the right hand side. So it's the most right, it's going to remove that. And then we are going to pop the one on the most left by doing pop left. And then we are going to clear everything and print empty deck. Okay. So when you run this, I put the string there so you can see the difference. Otherwise, okay. So when we, okay, to start, we append C, D, E, it loops through and it prints out each of the character for me since I use a for loop there. And then I print the entire deck after it appends. So I have a deck here. Okay, so that is this part. So that's where this is. Then I'm going to append A and B to the left when we talked about the order. So B get pushed in first and then A. So B in first and then A. That gives me A, B, C, D. Then we're going to append F, G on the right. So up this time we're going to put F, G here. And then we use extend. So that's going to give us H through L. Then on the next one, we are going to rotate. So when we rotate, you notice that the K becomes the last, and then the L goes in the front. When we did the rotate right, which is when we pass the 1. So it's going to take the last one off, and it's going to push it to the front of the deck. So when we say rotate, just means that it's going to take the tail and it's going to put it at the head, right? It rotates it. And then when we did a rotate left, we're going to take the L from the front and then we're going to put it back. Take from the front and put it into the back by doing the -1 here. So we're back to A through L. Then we are going to pop the right side. So we're going to get rid of L and we're left with K, A through K. And then we're going to pop the one on the left. So we're going to get rid of the A. So we're now left with B through K. Okay. And then lastly, we did a clear and we print the empty deck. Any question? And there are other methods that you can use with deque. It's just this is just some of the general ones I'm using so you can see. You can always find these information in the documentation. You can refer to collections for deque. Okay. And similarly, C++ has something like this. Okay. Double-ended queues. Question. Question. We're good with this one? Okay, so that was number 6. And then in the next section, it's going to talk about hash map. So dictionary uses hash maps, and it's good for insertion, deletion, and element access. And dictionary would be used for anything that you would have that will be more than the nested list, right? In the past, we've done dictionary in the review. We also done dictionary in the other class. So a hash map is just a data structure that would be associated with your key value pairs. It would assign a specific index to each of the key, and it would associate that value, which is stored, that the value into that's stored in the array or the list. The example that's shown below is just how you would hash a string, which is a list of character, and it gives you the hash value there. And then in the subsequent example, you're hashing that string, but when you use a mod with the mod 10, you're gonna get more of the narrow down the value a little better. So then you would have, because it's gonna take that and it's gonna divide it by 10, and any remainder that will be the remainder value it's gonna return. So index can also be obtained using the hash function. And so when you call hash, right, like this, then that's you using the hash function, and it works with different data types. So you can see that we can get a hash code of the string by just using the hash function. And then we can narrow it down by using the modulo or the mod operator by using the percentage symbol and then the value. Okay. So sometime when you're using hash maps, it does handle collision, but that if you might have 2 objects that have the same hash code. So that might be a challenge. And in the dictionary, it would be effectively used for the elements in the list to access, insert, remove, and so on. Is it using MD5? Oh, it's just an algorithm that they implemented. I'm not sure if it's MD5 or not. I haven't looked into what MD5 as an algorithm would be used, but I had it up earlier. Let me see, did I open it? No, I actually did. Yeah, so for the hash method, you can look into what algorithm they use. I don't think it's MD5. Since there are collisions, I would figure, yeah, it might be, but or MD5 actually uses that method algorithm. It might be the other way around, or so I'll find out. I'll let you know next time. Okay, so using the collections default dict, you can produce dictionary that would have new key generated from the default value, and default dict would then call, when you call it, it's gonna, and you have to pass the integer here, it would produce the dictionary where every element is assigned a 0 value to start, and then it would just do the counting. Okay, so something like this. You would import default dict from collections. That would be another class that you would use from collections. And then you would be able to build the dictionary by using, in this case, we define a function and then we loop in that function. So that way it would increment for each of the items. Okay. And you can also use the counter class from the collections. As you would see here, we would have counter, but in this case, we'll use a counter class, and we would need to just to pass items there. So in comparison, when we talk about speed, right, counter to for the number of input, you can see that it also jumped in the time. It increases the time. If we use counter dict, that would also changes in the time. It increases the time, as it would be dependent on the number of input. Okay, so in number 7, we need to describe how the hash map is used for dictionary element insertion, deletion, and access. We can simply state that hash map is the data structure that associates a set of key value pairs. It assigns a specific index to each key, and the value can be stored in an array. The index can be obtained by using hash function, and you can use that for several data element types. So you can go to the section for hash map. You should be able to see the answer there. Any question? Is there a reason why you wouldn't use Python built-in methods but build your own function for algorithm purposes? You can use the built-in method if it is a more efficient method. So if it, so that means that you probably should read their documentation on how that, what is in that function, right? The method that you're using. Or if you customize your function, you have the flexibility to make adjustment and modify it. Yeah, if it's already made and if it's about the same as efficiency, you can use it. But if your method is better than their method, then you can create your own method. I think the book, they just use that to show you how you can manually write it as an example. Okay. Because sometimes built-in method, right, requires, it calls other methods, and then, it use other library or other modules as well. So you have to be considering, what is the structure of that method that you're using or creating. So is it better one way or another? No, not necessarily. It depends. All right, so we are going to do a dictionary using collections and defaultdict. So what the book shows you there is that even in the same module, you can actually improve your algorithm by using certain class in that module, right? And in that class, you would then have member methods that you're using. So, you know, you would have to assess based on the goal of your program, what you're trying to achieve, and what you want to, how the efficiency is going to play as a key factor. So we are going to use the given list that's below, okay? And we are going to create what's called a default factory, because remember that the dictionary is also built on your simple list. So it is more than, it's you know, like three-dimensional, multi-dimensional list. That's what it is. So we are going to have a list, and we are going to use the defaultdict module for the default factory. And if you want to read more on that, you can go to the documentation. Here it talks about counter, right? And then it goes into counter objects for pattern. We'll touch on pattern later. Okay. And then it talks about deque. There's defaultdict objects there. Okay. So we would start with the dictionary. And you can use this example similar to what we have. Okay. So the dictionary would have keys. And when we look at this list, we can use, right, this. So this list is nested with many tuples. Okay. So we would use like the sizes, X small, small, medium, small, large, medium, as your key. And then the value is going to be the number of shirts, 20, 15, 50, 60, and so on. So we wanted to first display we wanted to create it using the defaultdict module from collections. Actually, I should say this is class. And we want to display the sorted dictionary. Okay. So here we go. Number 8. Really easy, actually. So you're going to do from collections, import defaultdict. Then you put in your list. Shirts. This is a list that contains tuples. So we nest the tuples into this list. So we have X small, 20, small, 15, medium, and so on. Then we create an object, D, and we would say defaultdict because we import that in, and we would use the keyword list. So there's only one list here. It's going to default that to shirts. And then I would use for loop for I and J in shirts, because I is going to be my size and J is going to be my number. I'm going to append, right? I'm going to rearrange this into this container and get it sorted. Print. So when we get this going, we would have large as 80, medium, that will be 50, and 65. It's going to combine this value and this value into a sublist. Therefore, it is a dictionary. And then we have a small. So we have two tuples that contain small. So we have small 15 and small 60. So it's going to combine the key and it's going to put the value into a sublist. And then the XMAL is last because we sorted by alphabetic, right? As ascending is the sort algorithm. So we would then have XMAL and it's going to put 20. Okay, so there you go. Using default dict. Any question? So now you can see how you can do this, right? And in this approach, we simply use the class from collections module, and then we use one for loop. So therefore, this will also be your O of n, right? Any question? So list is the keyword in this. Yeah. Yes, that is. You can use lists and you would refer to the list that you declare. So I can just simply place. So what it does is it put a list container there for me, right? And then we would then use the for loop to access the values. Are we doing any question? We still have like 4 more to go. So in the next 30 minutes. So in the back, if you think about hash map, right? What will happen is it's gonna have hash value for each of the keys, and the keys are these right here. Okay. And then what it's gonna do is gonna map it. So as small is the same, it's able to pull the data and group that together. Okay. The same thing with your medium. Your key is the same there and there, as it would compare the value, the hash value for that key. Same and same here. So it's going to group the data together there. Questions? All right. So that will be number 8. And then we just got one more program and a few questions, so we'll be good. Okay, so I'm going to move forward now. So in the next section, it talks about how index can be, when it searches for index, it can use hash map. And so in the case where if we want to create a data structure, we can use a method called inverted index. Okay. Which associates the string or the word to the collection of the list of the document that's presented. So you saw how that's done with the dictionary. Now, if you're seeking for a certain string, like search for it, you can use what's called inverted index. Okay. And in that, what it will do is gonna create a map, or it maps it to the index of the word or the string that is appearing, that's defined in your container. So here's an example. What they have is they have a list that contains different strings. Then what they would do is they would create what's called an index dictionary. And then they would use a for loop to go in and cut up each of the strings. So if it's multiple words in that string, it's gonna split it. And then it's gonna look for the keyword, okay? And as it split it, it's gonna map, it's gonna have a hash value, and it's gonna map. And so if the keyword matches the hash, that's how it's able to find it. All right. And that example is what I generally use. Okay. So when your queries go through, at the end, when you're looking for a certain word, right? You're seeking a certain word, like keyword that you're searching for. It's basically an O of 1, which is a constant function. Okay. So we are going to do the next one, number 9. It asks you to write a Python program that uses inverted index to search for the term brown in the list. Okay. And we have a list of animals. We have brown cow, black cat, yellow bird, red rooster, brown horse, and white rabbit. We want to look for the keyword brown, or the word brown. Okay, so first you would need to, is that number 9? You would need to define your list that's given to you there, and keep in mind that these are strings. We would then split the words into half for each of the string, and then be able to map it back and find the word brown. Okay, so what we're showing you here, what I'm showing you here, is a way to search with string. Okay, instead of iterate through every single character, or split it first and then iterate to see the character match, that's too long. So there are different algorithms that we can use to search. So for my key, I put seek. Okay. And I wanted to show you that this is one way that we can seek it, is through iteration. Okay. The actual inverted index section is here. So originally we can just loop through it, right? We would have color for color in animals if. So it is a nested if inside a for loop. We would say, oh, look through every single string. If there's the keyword brown is to match, then we would find it. Okay, that's one way. And that's not the efficient way. Even though there are more coding here, right? There's more scripting there. An inverted index way is you would then initialize an index dictionary. You would then have a nested for loop and also an if, very similar to that. But in this case, what we're doing is we're saying for every single index, right, we would then enumerate through this list, and we are going to look for, we're going to loop through it, we're going to cut it up into, we're going to split it. Okay, so first we're going to access each of the string, then we're going to loop it again to split the string. And as it's split it, we would have the if statement. If the word is not in the index, which is our brown, right? We're going to map it to the index location for the word. Then else, we are going to append that to the list. Then if our index contains the word brown, then we are going to show it. Okay. So ultimately, we would index all the items in animals, and that's how we're able to find it. Okay, so run. So in the iteration, it tells me that it has brown cow and brown horse. So this one and this one, that's true. Okay. In the inverted index, I'm able to find where it is that it found it in the first string, which is position 0, and in the fifth string, which is position index 4. Okay, so in some cases, you don't really have to really change anything. You can just access it and find it where it is in your container. So you can use this, right, to look at the index. And at this point, we would have, this is going to be your O of 0. Oh, of 1, I'm sorry. And then at this one, it's going to be O of n. So then here, and then on these, that will be a n squared, O of n squared, and then this is going to be O of n. So here we would have also the same result, brown cow and brown horse. Okay, so now you know how to do 2 types of search. One is linear, which is iteration. That's also O of n. The other one, a little bit more complex, you would do inverted index. Any question? So as far as storage goes, right? You have seek is going to be storing a list, and it's going to print out that list, which contains what it had found with brown cow and brown horse. Okay. Based on a for loop and a nested if. So I have O of n on the outside, O of n on the inside. So that will be O of n squared. Then for the inverted index, what we did was, instead of the storage is still going to also be a list, But what happened is we're only going to store, first one is going to be just the number, right? The index number that would contain the word brown. The second list that we store is going to be the actual string, the toString that contains the word brown. Okay. I mean, if I only wanted to show this, I can omit this part and that would reduce it. But if we wanted to find the index, we simply just have the result there so we can print it. Okay. So if you only need to find the position, it's actually just going to be O of 1 there. All right. Next part, sets. So in the prior class, we touched on sets, right? You can use set operations, and set operations can be like union, intersection, difference, symmetric difference, and so on. What shall are you using to get? Oh yeah, so that's you can use that on IPython. From my console, your console. Yeah, so you can use this, but I think you the book, it talks about how you can use Jupyter, which, you know, and IPython is with Conda. So if you install Conda, you can run IPython. Here, oh, I showed this right here. I'm using Tawny, and Tawny uses the standard shell that would be, that's why you see that, but yeah, it's going to show that every time that I run it. But this is a magic command, right? It's just a run command in IPython. Yep. Okay. Other questions? No other questions? So real quick on sets, it talks about how when you implement sets operations, when you union the two sets, when you look at the intersection, this is going to be your time complexity. So if you do the union of S to T, that's going to be the input from S and the input from T added. If you do the intersection, that will be a subtraction of S and T, S number of input, and then the difference, it will just be the from S, right? So that will be the difference. It's just going to be the first set input. Okay. So the efficiency for that, the way that you can improve those is to be more efficient, is that you would use indexing, if possible, for the sets, depending on your main objective of your program. So here it shows you some of the operations, like the program that we just, similar to what the program we did. Okay, so it uses the inverted index there. And then when they did the intersection here, you can simply use the index where it would find cat and the index where it find table, which give you O of 1 and O of 1 there. So, you know, because it's looking for a specific word in the group of strings. So that's another way that you can use it with sets. I didn't really write the exercise for this, as we already did something with the inverted index already. Okay. And then for heaps, so heap is just a data structure that would have you can use heap queue in the collections, but heap in general, it would have like user data, um, and it does have a ceiling, right? So you have the stack and then you have the heap. So all that is just memory location where we can store data. Okay. Can you create a structure like heap? Sure you can. And basically you can use our traditional list container. Okay. But they did build some of the methods called for heap queue, and the documentation, the link is provided there. So in collections, it also referenced some heap information, but you can actually push in a value. You can pop, I'm sorry, an item, push an item and pop an item. You can do a push pop. Okay. The whole point in heap is to not let it grow very large. What we want to do is we want to use it and then get rid of it. Okay, modify it, use it, get rid of it. So what we want to see is we want to be able to change the content of a container and limit it. Okay. So this is why you would normally see a push and then a pop right away whenever you see the program for heap. Okay, so this is an example for that. So in some example that you will find on the web, right, you might find sort algorithm using heap, search algorithm using heap. So it's just a data structure that you would be able to use, and it would have different methods that we can implement to introduce the item into the container and then get rid of it, okay, or modify it or access it. So, and how you use this data structure is really going to speak about how you utilize your resources, like your memory, your memory for your application, and that's going to help with the efficiency for your program. So what they're showing you here is just a way to sort, right? All of these numbers using heap sort. And the heap sort is defined here where they would have a list and then they push the value in. So we insert the value there, or we push it in, I shouldn't say insert because that's a different thing. And then as we access it, we're gonna get rid of it. We're gonna pop it out. Okay. So once it shows that, it's gonna get rid of it. And then here's another example how you can use the methods. And then it's going to go into priority queues and other things. I encourage you to read the documentation because it's going to give you more details, right? Like how you can do push pop, how you can, if you do a heap pop, what is it going to return? Okay. So to answer the next question, oh, sorry, I should go to the cache. So here it talks about heap, okay, and then showing you how you can use the method or even priority queue, which is another class. So it's just how to work with the container mostly. And if you're familiar with C, right, there's catch and try. There's no tries in Python. There is a third-party module that you can use called Patricia Try, right, which is a file, and then you need to make sure that you include, you introduce that module to your program. So we need to import certain element of that module and be able to do that. Okay. Lastly, it's going to be on caching, and we already know what caching does. It's just a way to temporarily store something that is frequently used. It's very useful for web application. It's very useful for application that access the same type of data continuously. In networking, caching is so important in routing and switching. If you have system that regularly connect, the cache information really help with, the connection speed and the overall performance in your network. In applications, if we cache something, we can regularly that's regularly accessed, we can then refer to that location in the memory and be able to retrieve the data when we need it. So it's just a good way for us to streamline some of the process instead of starting all over again for certain requests, for certain type of access. So it is a way to store and reuse. And it would be the term memoization, which is how we would take advantage of the temporary location and be able to improve the performance and the overall algorithm for our program. Okay. And Python has a module called functools. This is a way that we can write cache into the actual program. Okay. There are decorators that can be used when you implement certain methods. So here what you see is you can use the the LRU cache decorator, which can cache the result and later be accessed. So the example for this is provided in your text. And the decorator uses the @ symbol. So here what we can do is we can state that we are going to cache the result by using that, and at the top we would import in the LRU cache method, which is from the functools. Okay. And so if we run this program, and if it's executing this function to sum, right, continuously, we can quickly be able to obtain our result. And that's the point in caching. So to answer the next question, it asks you, explain why caching is useful in development. It is a way for us to improve the algorithm by storing and reusing data that is already computed. So if you do have the textbook, I encourage you to take a look at the example program, right? For the sake of time and because of the holiday, I might come back to this in the future chapters, and then we will revisit some of this, but you know that this would be an option, and there is a module that you can use. So here I included the example in the notes, so you can see some of this. They show you how you can use it for Fibonacci program. So, especially when you're looking at something that would be classified under recursive, right? Using recursion, that will be perfect for caching. Okay, a function that calls itself. And then it talks about how the changes in the performance where it would be, that would be implemented with memory caching. Joblib is another module, and this uses the memory class. It's a way that we can implement memoize function. So another way that you can include, right, cache in your program is to use joblib. And this, you would have a decorator, okay? And you can actually specify where that cache is stored, such as directory, folders, and so on. Why is that important? Well, we might need to also be able to identify where that data would be cached so we can also retrieve it, right? You can set a specific path instead of just random location in the memory. And this is another way that you would do that, is to use joblib. So in the next question, it asks you, in Python programs, which module can be implemented to use memoize functions for caching purposes? That will be your joblib module, and you would need to use memory class. So you would say from joblib import memory with the capital M. And please see the example in that section from your text and notes. And when we work with dictionary in 30A, and also we touch on dictionary today, to comprehend a dictionary, all that is just to access the key and its value in a dictionary. So an efficient way to do this is to write a function or a method that would map, right, the key of the dictionary and use the generator to access the value or the elements in that dictionary. So you would need to comprehend the dictionary using mapping and generator. So in the case where you would have a very large dictionary, that will be very useful. Okay. And the example that's provided in the notes for the last part, it talks about using the generator and the map, which is the map method. So here from 13 to the end, which is 16, it shows you how you can implement that, okay, for dictionary. So in dictionary comprehension, usually we just do loops, right? Like you saw earlier, we can run a for loop and access each of the index and then so on, okay? So that's the traditional way. The more efficient way is then we would then use mapping. So you would define a function and then you would then have sublocation that would map to, you know, values that you calculate from another container. Then you can use the map method. And in this one, you would use lambda. Okay. So this would eventually save you memory allocation, and that allows us to efficiently build the program. Okay. All right, that concludes the session for today. Do you have any questions? If you have the text and you download the code or the script that's provided with the textbook, note that it uses Jupyter in this particular chapter. If you're not familiar with Jupyter, a lot of school uses Jupyter. Either they have the server or a product that's similar to Jupyter. I know you can use it directly in the browser. It's just a shell that you can run, and you can also import file. You can install it, or so the notebooks is the version that you want to use, and it's able to run Python. So if you install it, you would do Jupyter Lab, or you would need to run it in the browser. So the classic notebook you can run here. If you wanted to run it for R, you can run it here. This is commonly used for data science. Jupyter you can use it to keep notes, just like a regular notebook, but at the same time, you can run script with it. You can analyze data. So you can record your data and run your analysis all in one. That's the whole point. And then there's C++, which is used for like development analysis, and then R and Python often are used for data analysis, data science. Okay, so you can try Jupyter Notebook, and it's going to go through the binder like this. So notice that it's using IPython. So the files that they give you, you can incorporate with Jupyter. Okay, but read the tutorial, or sometime you can probably find video on how to do that. And since it uses Conda in the back, you also have access to IPython. So there you go. That will be another option. Any question? Okay, I'm going to stop recording.